Hello. Give it a few minutes to wait for everybody to join the call. But hi, guys. Hi, Anne. How are you doing? Just going to give it a few more minutes for anybody else to join, and then we'll get started. And if you guys have anything you want to ask throughout the session, if you can unmute yourselves, or if you can't, just send me a message and we can sort that out. Thanks. Hi, Sarah.
Hey guys.
I think we just give it until about 5 past, Sarah, and we can get started.
Yeah, cool. Cool.
Great stuff. So yeah, while we're waiting for everybody, I guess I'll introduce myself, and Sarah can as well. So my name is Fiacre. I'm on the STEM Academy Mission to Mars team here at Dupuy. And for the last few months, we've been putting this program together for you guys. So we have this course over the next few weeks. Today we're going to be looking at some bottle rockets and some looking at how that works, looking at the science behind that a little bit, the physics and the chemistry that's going on there. And we're going to talk a bit more about space in general. We're going to talk about space science and space exploration a little bit. And over the full 4 weeks, we're going to have a bit of a theme going through them all. So we've got this story where we're following these characters from Earth to Mars. And as we go along, we're going to be looking at the same kind of things that they're looking at the whole way through the whole program. So in a few minutes, we will start off with our animations. We'll look at the start of our story, and then we'll get into our kind of DIY bottle rockets that hopefully you guys have the materials for. Then we'll put them to one side for a bit. And we'll talk a bit about the science, have a bit of a back and forth, a few questions. I'll ask you guys some questions, you can ask us some questions. And after all that, we can actually launch our rockets. And if you guys have any questions at the end, we can take some questions there as well. And at the very end, we've got a bit of a challenge for you guys for the next week as well. So that's kind of the plan for today. Does anybody have any questions at the moment, actually? No? All good. Does everybody know how to unmute themselves if they have any questions, or to send Sarah a message if you have any questions? Yeah?
Yeah.
Very good. Okay, great. Okay, just give it a few more minutes. There's a few more people trying to join, and then we'll get going.
Do you guys want to tell us your names while we're waiting? Who do we have?
Us?
Yeah.
I'm Alex, he's Ben.
Hi, Alex and Ben.
Hi.
Nice to meet you guys. Anybody else? No, that's okay. We'll get going.
It's Anne here. I just wanted to let you know that I think maybe 1 or 2 people were having some problems getting in.
Oh, really?
Yeah, I don't know if that's been resolved now or not. Just thought I'd
Okay.
let you know.
That's
I wonder,
grand.
can we send the Zoom link out again to everybody on the list, maybe?
Yeah, I don't know what those difficulties are coming from. Was it do they have the Zoom link? Do you know, Anne?
I don't know. I know Mark seemed to be starting another meeting, but actually, I just see he's joined this call now.
Yeah.
So I was just wondering.
Yeah, the Zoom link wouldn't work for me. I tried 2 or 3 times for it to work. So then I
Okay.
tried
I wonder,
Um,
could we maybe send it out again, just quickly, to everybody who was on that list?
yeah, would you be able to do that quickly there, Emma, if that's okay? If you have the message that you sent the last time, you can copy those emails and just send it to them again. Can you hear me, Emma?
See, I'm just not sure who was on the list. I can't send it, or else I would.
Hello. See if I can get it up here. We'll start in a minute, anyways. Do you have access to the email, Sarah?
I don't. I haven't been on it. No, sorry.
You can't hear me, can you, Emma?
No, I can hear you.
Oh, cool. Could you send an email out again, please?
Yeah, I'm sending the link out now.
Oh, brilliant. Thank you. Thanks. That's great. Sorry, I wasn't sure if you could hear me. I think you're on mute. That's great. Okay. Well, I think we should get started anyway. We can recap everything at the end, and it's all going to be recorded here. But we may as well get started now. While everybody's here. What do you think, guys?
Yeah, cool.
Great. Okay. So I will start off with our story here. Give me 1 second. Can everyone hear that okay? Great.
Five, four, three, two, one, zero.
Okay. And we're off. Or is it? Can everybody see me again?
Yep.
We're all back in the room. Okay, great. Okay, so that's the start of our story. Our astronauts are in space. They're on their way to Mars, and we're going to try and join them now as well. So the next step of today is we're going to look at our bottle rocket. We're going to look at making that. They were going to put it to one side, and then later on we're going to actually try and launch these rockets outside. So the next step is I have a tutorial to show you guys, recorded by David, who's also on our team. And after that, I'm going to walk you guys through it as well. So I'll share my screen again, and I'll show you the tutorial.
Start with a clean, empty plastic bottle with the label and lid removed. Create the nose of the rocket by wrapping a piece of paper or card into a cone and then taping it to the bottom of the water bottle. Personalise your rocket as best you can. We will put up photos of each rocket on our website. Tape 4 straws, pipe cleaners or pencils to the bottle. These will be the legs of the rocket to stand on before launch. Fold a tissue in half and in half again so that you have a small square. Add a spoonful of baking soda to the centre of the tissue. Roll up the tissue with the baking soda inside and twist one end to keep the baking soda in. Half fill the bottle with vinegar. Hold the tissue in the opening of the bottle and wedge it against the mouth of the bottle as you insert the cork. Your rocket is now ready for launch.
Okay, so that's what we're going to do, guys. I'm going to walk you through it now. We're going to do it slower. We're going to do it together. But yeah, if you guys have any questions as we're going, just unmute yourselves, ask away. There's no problem there. So we will start. Does everybody have a bottle?
Oh,
I haven't got my stuff ready yet.
Oh, that's okay. We can wait for you. That's no problem at all.
that's good, guys.
Great, guys. Getting a few more people joining here now. Did you get that email out okay, Emma?
Sorry, I'm just sending it out there now.
Great stuff. Thanks very much.
Has anyone built a rocket before?
Cool.
I have in school when we had to bring some stuff for recycling, and we each table made their own rocket.
Great. When did you do that?
In November, I think.
Oh, brilliant. We've got an expert here.
Cool.
Great stuff. Anybody else? We got some more people joining now as well.
I sent the link out there.
Great. Thanks, Emma. So if anybody has their bottles ready, you can get started. I'll be here to answer any questions again as we go, and so will Sarah, Aoife, and Emma, and Mark, who's here as well. So the first thing you're going to want to do when you have your bottle is to make sure that it's all empty and you take off the lid. And the next thing you want to do is to make the nose of your rocket. So does everybody have a bit of paper?
Cool.
Great stuff. So what you're going to want to do here is to kind of start at the corner and kind of roll it up so that it's creating a point at one end.
You want to make it look like an ice cream cone.
Great stuff. Thanks, Evan. Or Aoife. And then once you have an ice cream cone, you can just put a bit of tape on it, a bit of sellotape, just to hold it in place and keep the shape on it. Great stuff, guys. That's what mine looks like. Then once you have that taped, you can just cut off the bottom of it, so it'll fit nice and easy on the base of your rocket. Are you guys okay there? Garrett, can we help you at all with connecting to the audio?
I Maybe it's headphone problems.
Could you send a message into the chat there, Sarah, actually?
Yep, no problem.
Thanks.
It's looking good, guys.
Nice one.
Oh, it's just an audio issue with Garrett.
Has he tried the drop down from the mic button on the bottom left corner? It might work easier without the headset even.
Okay.
Are y'all getting on okay with the cones?
I don't have sellotape right now, but
Okay.
the cone
That's okay.
on
That's
fine.
okay. You can still do it without the cone. It's fine. It's just to
That's
make
okay.
it look pretty.
What we want to do for the next week as well, anyway, is once we finish this session, you guys can go away and kind of design your rockets more, put a bit more kind of decoration on it, and then if you send us in your pictures of the rockets, we're going to have some prizes going as well. So you know, there's no rush. Basically, there's no rush to work on the design. It's looking great, guys.
Could be a Wi-Fi issue, Sarah, maybe with the audio.
Me. See that there's no option for me to do anything, unfortunately.
Is
Oh, here we go.
Oh,
Oh, there we go. It worked.
hello.
Um,
Can you hear?
Or-
Oh, sorry. Go on there.
do you tape these straws to the bottle rocket?
Yeah, absolutely. So we can do that step next if you guys are ready for it. But as well, everybody else, there's no rush. I can talk you through it again. So yeah, if you have 3 or 4 straws, I'd recommend you kind of tape it above, tape it so the bendy bit of the straw. Just keep the tape below that, and you tape it here, and just tape 3 or 4 of them around the whole edge of the rocket.
Oh, we got some decorations there as well. That looked great. Can you hear us okay now, Garrett? Is it working okay? Oh, I think he's muted.
Can you unmute yourself there, Garrett? Or I'm not sure if is that
If
you,
it is Garrett. Can you click the bottom left? Mute?
Yeah, no.
There we go.
Great.
Yay.
Gotcha. So what's your name?
Gareth.
Garrett. It is Garrett. Okay, great. How are you doing, Garrett? We got you in the end.
Are you going to be building a rocket, Garrett?
I don't know.
Don't know. That's okay.
That's okay.
Cool.
We're recording this anyway, and it'll be on our SharePoint if you want to do it at any other stage. There's no rush.
Okay.
So, if you want to join us, if you're able to join us, that'd be great. But if you can't, you can do it another time. That's no problem at all.
Yeah, I'll have to do it another time because I don't think I've any of them items.
That's okay. That's okay.
Are the rest of you getting on okay?
Looking good. Oh, there we go. We got Tia.
Yeah.
Cool.
Also, you want to make sure that the legs of the rocket are the right length, so that it actually stands properly. Because it's easy to get that wrong. Like I just did. We played the animation again for Garrett.
Yeah. Cool.
I know there's probably a bit of difficulty at the start, Garrett, but just so you're up to speed with our story, I'll play it again here. Because we are following this throughout the whole 4 episodes, and I wouldn't want you to miss it. So I'll just share it here quickly. 1 minute.
Okay.
These are a series of animations that we're going to be doing following our 3 astronauts as they go to Mars.
Right.
Five, four, three, two, one, zero.
That's our story.
Mine won't balance. My rocket won't balance on its legs. It keeps on falling.
Oh no.
So mine was doing that as well. And which direction is it falling in?
Hmm?
So it's falling towards you, is it?
No, like, maybe I put them too much on one side instead of in the middle.
Okay. Do you have any more straws, or are you using straws or pencils, or
Straws.
do you have any more straws?
I don't know. Wait, I think I might be able to fix it.
Brilliant. Yeah, you want
Those
them to
rockets are looking great, guys.
be looking brilliant.
Who was finished first?
Some decorations going on now.
Unreal stuff.
They look class.
Okay, guys. So if you guys are ready for the next bit, what you're going to want to do next is to pour in some of your vinegar. You have some vinegar. You don't want to fill it up the whole way. You probably don't even want to fill it up the whole way to the halfway point. You probably want it about a quarter or about a third of the way up. Yeah, probably about that much.
Did you get it to stand up? Is that it working? It looks, oh no, nearly.
Do you want to try put some tape a bit lower down on the straws maybe? It might stand for you better.
Yeah, put some more tape on. That's looking great.
So we have a question about the cork. When you say a cork, are you talking like a bottle of wine, like a cork like that, or is it just a bottle cap? Or
Yeah, so it's a cork. It's cork. Like, I know in our video we used the cap because we were putting it away again. But yeah, it's just like a wine cork, like this. If you have one of these. And if it doesn't fit perfectly into the neck of the bottle, you can do a few things. So what we're using is a couple of rubber bands to kind of make it a little bit wider. What works even better than that is if you have some duct tape or some gaffer tape, and then you can kind of make it a bit thicker by wrapping the tape around the edges.
Mine's too.
Okay, thank you.
No problem. That looks brilliant. Well done, guys.
How much do you need to fill the bottle with vinegar?
So about a quarter. So it's about, if you can kind of see that there. Is that clear?
Mm-hmm.
It's kind of, yeah. Is that pizzas you have on your rocket? Looks like slices of pizzas.
Stickers.
What's that on the top? Very nice.
Cool.
Nice work. Nice work. So, do you guys have some vinegar? Do you? Yeah. And is it in your bottle?
No, not yet.
We're trying to get the cork situated because if
Oh,
I put
sure.
it over, it will.
Yeah, I get you.
Some donuts on the other rocket. Donuts and pizza.
Lovely.
Cool. Love it.
In the meantime, what you can do is if you cut out a square, or if you have some tissues or some tissue toilet roll. I'm using a napkin, and it's like a small square. That's what we're going to use to make our packet of baking soda. Does everyone have some tissues or a little bit of napkin or anything like that?
I have a kitchen tissue, but it's big. Is that okay?
Yeah. Even if you like tear off a little square, or if you cut off a little square or anything like that, then that'll be perfect and good to go. And yeah, I'm using the same. I'm using a kitchen towel. And once you have that, what you're going to want to do is just take a little bit of baking soda, and just put it in the middle of that napkin.
How much?
So like a spoonful.
Like a teaspoon, or?
I'm using a tablespoon here. A teaspoon. Yeah. I'd use a tablespoon.
This is a teaspoon.
Tablespoon.
Is everyone getting on okay, yeah?
Nice one, guys. And then the last step, once you have the vinegar. We're going to set up the baking soda, which is going to be our fuel for the rocket, and then
I'm putting in the vinegar right now, and I have my baking soda out.
brilliant, great stuff, good work. And we're just going to fly through this a little bit, because we want to give you guys a bit of a lesson as well, and we know we're going to run out of time a little bit. So once we have it all set up, you're just going to we're going to put the rockets to one side, and just make sure that you keep it turned. So if you lean it against the corner somewhere, and make sure that you don't turn it over yet, because you don't want it to go off in the middle of the sitting room. So for the baking soda, if you pour it into the middle of your napkin, and if you fold up the end of the napkin, so I'll show you what I mean. If you make a heap in the middle of your napkin even, and you pull up all the corners, so you have like a little pouch. So you see I've got a little pouch here, and I've got the baking soda inside my pouch. And just make sure that you keep it like a little packet, basically. Nice one, guys. That looks great. And if you have the vinegar in your bottle, what you want to do is very carefully put your pouch inside the neck of the bottle, but don't let it fall down into the vinegar. You want to, losing it here a little bit. So what you're going to use the cork to wedge the pouch against the neck of the bottle.
I have a question.
Yeah, go for it.
When I should put it in, the opening should be inside the bottle, or when it's like closed?
So yes, you want the closed ends to go into the bottle. So if you see it like here, I've got the pouch inside the bottle.
So over here, the opening, I should just put like the end inside here.
Yep.
Yeah, perfect.
That's right.
And then if you keep a little bit of tissue out the top of the bottle, then when you put your cork in against the tissue. So I'll show you what I mean here, right?
We just don't want it to fall in just yet. Just make sure it doesn't fall into the vinegar.
If you see right here, I've got the tissue, I've stuck in my cork, and it's kind of wedging the top of the tissue against the neck of the bottle. And this means that when I turn the bottle over, the vinegar is going to come down to where the baking soda is, and it's going to have its reaction. Does that make sense?
Not really.
Okay. Yeah, how can I help you with that?
Do you have a lid or do you have a cork?
I have a lid.
You don't have a cork, do you not?
Nope.
Okay. Okay. Well then, I suppose the best thing to do is after this session, if you can find a cork, if there's any corks in your house, then you can do this. We'll have this recording as well. So this will be here to help you along the way. But you will definitely need a cork to be able to build up the pressure inside the bottle. Because otherwise, it won't be able to push a lid off. So the cork is important. That looks great, guys. Really well done. So once this is here and ready to go, we're just going to put these to one side.
We were just asking if a lid would work the same as a cork, but I don't think it's going to work.
Yeah, I don't think a lid would work very well because the lid won't be pushed off. The lid won't build up it'll build up pressure, but it won't be able to get off.
No.
So you do need to, you need a cork.
Oh, we have some people setting off their rockets there, I think.
Oh, exciting times.
Yeah, should we go give it a go right now, or?
Give it a go. Yeah, why not? If you're there.
So,
You're gonna.
oh, you're gonna do next.
Yo, come. Where you guys doing? Just do it right here on the front walk here. Oh, okay.
So just do one at a time. Like,
Oh, you got to stand it up. Stand it up.
Oh,
Oh, it's not pushing the cork out. There it
Oh.
goes. There it goes. It's pushing. It's pushing.
is it going?
Nothing.
The tissue got stuck.
Oh no.
Oh no. That's okay.
What happened there? Oh no.
Oh,
So close.
that's okay too. Just means you'll have to try again, I'd say.
Yeah, that's okay. That's okay.
Oh,
That's
no.
the idea anyway. The idea is there. We want you guys.
Ben.
to kind of-
Oh, yeah. Well, here. We'll try it again later, Alex.
Can I do mine?
Yep. Let's try yours, Ben.
So what do I just flip it?
You bring it over here. Yeah.
So
Try.
just flip it and stand
you
it.
wanna
Yep.
loosen
You're gonna
up the
stand it
cap
up.
a little bit.
Well, I think the cap on his tissue's already like laying. See how
Yeah,
his tissue's
yeah,
like laying down. Come on, bring it over
Oh,
here so you're on the camera.
What is the camera? It's okay. This is just all trial and error.
Ooh. Oh, you see that was the problem with the bendy straws.
Oh no, the bendy.
The bendy straws.
Oh no.
That's okay, guys.
Oh yeah,
That's great.
maybe the bendy straw.
Yeah, a bit of work on it, and I'm sure you'll get it before next week. That's great. Good effort, anyway, guys. Brilliant stuff. I want to push on because I know you weren't able to join us with the rockets today, Garrett, but we have some other stuff for you as well. I want to push on with a bit of a lesson, and we can come back to this at the end. So if you just kind of set this to one side for now, because I'm also conscious you might have other stuff to be doing for the rest of the day. So I'm just going to share a bit of a presentation, and we're going to talk about how this actually works. We're going to talk about the science here and the physics a little bit, and also about rockets in general. So we're going to move on to that for a little bit. I'm just going to share this here. Oh, 1 second.
Does anyone know anything about rockets themselves?
No.
No? Good. We've loads to learn, so.
Sorry, 1 minute. Share screen. Trying to get the full presentation up here. I think we have it now. Yes.
If you just switch your settings around.
Yeah, it's actually blocked. It's blocked by the taskbar at the top.
Oh, okay.
I think I have it now.
Do I just talk through some of it, or?
Yeah, I have it here now. Can everybody see that okay?
Yep.
Yeah.
Okay, brilliant. So yeah, today just going to want to talk about kind of the history of space travel a little bit, history of rockets, gravity as well, and how those bottle rockets that you're making actually work. So first off, does anybody know anything about space travel? Anything about rockets? You know, the history of rockets, moon landing, etc., etc.
When rockets go up, after a while, their boosters at the side fall off, and then afterwards, I think it's called the main engine. It also falls off, and then the top of the rocket, it keeps going to the moon, and then when it comes back to Earth, a parachute comes out of it to stop it.
Brilliant. Yeah, that's absolutely right. That's absolutely right. That's how it works. You know, the boosters fall off, and they get dumped basically. And actually, at the moment, they're trying to design rockets that don't do that. They're trying to design rockets that land themselves, because you know it's not great for the environment. It's not great for the companies as well if they're losing all of this material every time they have to launch a rocket. So that's brilliant. Well done. Just to talk about space race in general and kind of the different launches that have happened since space travel began. So the first launch was in 1957, and it was actually the Russians who launched the first satellite. So they launched the satellite Sputnik into space in 1957. And then in 1961, the Russian Yuri Gagarin, he was the first man to do a spacewalk. So he was the first person to go out of a rocket in space and basically float around in just above the atmosphere. Does anybody know what the difference is between an astronaut and a cosmonaut?
Cosmonauts are from Russia, and astronauts are like from the United States of America or other places.
That's absolutely right. Absolutely right. Yeah, yeah. There's no actual difference between like what they do or their jobs. It's just where they're from, and they're just called different things. So that was Russia. Russia kind of got the head start in the space race, and then in 1969, the USA landed the first man on the moon. It was Neil Armstrong was the first person to walk on the moon, and he was on the Apollo 11 spaceship, and their crew from NASA, from the USA. So that was the space race. Can anybody name any space agencies then? Any of the space agencies around the world? There's a few different ones, so I'll be interested to see if anybody knows any of them.
NASA?
Yeah, NASA, absolutely, that's one of them. Anyone else? Any other answers? NASA's the big one anyway. So we have NASA, obviously. Then Europe has one as well. Europe have the European Space Agency. There's the Chinese National Space Agency as well in China. And then there's the Russian one as well, which is called Roscosmos. But obviously that's the Russian name for it there. And then they're all public, so they all belong to like governments and stuff. But there's two private companies as well. There's SpaceX and Blue Origin. And at the moment, they're trying to make kind of space. They're trying to make space agencies kind of public, so that people could actually pay to go into space. You know, you could go on holidays, you get into space that way. And SpaceX are trying to get people to Mars as well. So there's lots of interesting stuff going on at the moment in space travel. So can anybody tell me any of the different challenges of getting a rocket into space? Because there's actually loads. Any ideas? Anything that might be difficult about launching a rocket?
They need to get the tools, the materials.
You do. You do. There's lots of tools and lots of materials. They're very big and very expensive. You need a lot of fuel. You need a lot of fuel to launch these rockets as well. Fuel and money. And then in terms of like the actual science behind it, obviously, you have to, we're all stuck on Earth because of gravity. So you have to actually get your rocket to overcome the force of gravity, which is very hard to do. So we're going to talk about gravity a little bit. So gravity is what keeps us on the Earth, basically. It was first discovered by a guy called Isaac Newton in 1687. And the story goes that Isaac Newton discovered gravity when an apple fell on his head. So he was sitting underneath a tree, and this apple fell on his head, and he realized that himself and the apple were both being pulled towards the Earth because of this thing called the force of gravity. Like if you look at Earth, it looks like, when you look at it at the globe, it looks like Ireland is standing on it and Australia is standing on the bottom. And you might think, oh, why don't you fall off if you're on the bottom? But it's because gravity is pulling everybody towards the center. It's so exactly like that. It's that's why we fall back down to the ground when we jump, because we have this force that's pulling us down. Our legs push us off, and the force of gravity pushes us back down again. So for rockets to get into space, they need to overcome this force of gravity. And gravity, everything experiences gravity. This is the interesting thing. Any two objects get pulled together, but it depends on the size. So your hands actually get pulled together by gravity. This scissors and this sellotape get pulled together by gravity, but they're so small in the grand scheme of things, you can't actually notice it. It's only when one of the objects is really, really big that you can actually feel that force. So the Earth is big enough for us to actually feel its gravity, for us to feel it pulling us down towards it. So that's one of the interesting things about gravity that you might not have thought of before. But are there any other examples of gravity that anybody can think of? Because obviously we get pulled down into the Earth. We can, every day that's something we experience, but there's other things you can see on the planet as well that are examples of gravity. Can anybody think of any? There's two big ones. Takes a little bit of outside of the box thinking. They're kind of difficult. So the first one is, does this mean anything to anyone? Waves. So tides, every day, if you go down to the sea, you'll see that the tide rises and the tide lowers throughout the day. And that's because of the moon. So as the moon goes around the Earth, it pulls on the tide. It has a gravity because it's really big as well. Not as big as the Earth, but it's still really big. And as the moon goes around the planet, it pulls the waves in different directions. And that's what creates tides. That's why if you go down in the morning, the tide might be lower than it is in the afternoon. So that's one example you can see every day. And the other is the sun. The Earth, we're pulled towards the Earth, but the Earth is pulled towards the sun because of gravity. And that's why we go around the sun, and we don't fly off away from the sun because the sun is pulling us towards it. And because we're pulled towards the sun, we go around the sun every year. That's how we experience days. That's how we experience seasons. So gravity is actually something that's really important, and it kind of defines a lot of how we live our lives. So that's kind of what we want to cover to do with gravity and physics. But now just to talk about the bottle rocket for a little bit. So we talked about the force of gravity. And when a bottle rocket launches, it has to have a force that can overcome gravity. So we call this force that a rocket or a bottle experience, we call it propulsion. So the bottle, we say it's propelled upwards because gas gets pushed out of the bottle. And as gas gets pushed out of the bottle, that pushes the rocket forwards, or upwards in this case. And this is again, the same guy we were talking about, Isaac Newton. This is one of the laws he came up with, one of the physical kind of ideas he came up with, was that every action has an equal and opposite reaction. So what that means, it's getting a bit complicated, but what that means is that when the bottle pushes, so the force of the jet of the bottle pushes out of the bottle, and that pushes the rocket forwards. And if that force forwards is strong enough that it's stronger than gravity, then the rocket is able to launch. So that's basically how the bottle rocket works, how the physics of it works. Does anybody have any questions at this moment? We all okay? Great stuff. So acids and bases. So we're going to talk a little bit, very basically, about the chemistry that goes on when you launch these rockets. So does anyone know what an acid and a base is?
Go ahead.
Oh, is somebody muted, or is somebody trying to talk?
Oh, there we go.
Oh.
Oh, we kind of lost you there.
Thank you. Yeah, are we having technical difficulties?
I think so. That's okay. Sure, we can try it again if it comes back.
That's okay. Yeah, I think we're having some Wi-Fi trouble there. But we'll press on anyway. Basically, when you're looking at so there's this thing called the pH scale, and the pH scale goes from 0 to 14, and water as a liquid has a pH of 7. And any liquid that has a lower pH than that is an acid, and any liquid that has a higher pH than that is a base. And that's the only difference, you know. They're just two different types of materials, two different types of substances, and you can measure this pH value. And acid is lower than 7, which is lower than water. Water is neutral, and a base is higher. Now, when we're launching this bottle rocket, vinegar is an acid. So again, as I said, vinegar has a lower pH number than water. And baking soda is a base, so it has a higher pH number than water. And whenever a base and an acid come into contact, they react with each other. They react in each other. It's called a neutralizing solution, or a neutral reaction. And this creates water when an acid and a base mix. You call it an alkali if the base is dissolved in water. And when an acid and a base or an acid and an alkali mix, they react with each other to form water plus something. And in this case, they form a new acid called carbonic acid. So carbonic acid has a gas in it called carbon dioxide. And this is the same gas that we all breathe out. You know, we breathe in oxygen, and we breathe out carbon dioxide. And as this carbonic acid is formed in the bottle, when these two liquids, when our vinegar, which is an acid, mixes with our baking soda, it forms carbonic acid, and this releases carbon dioxide over time. So when we have the cork in our bottle, this gas is building up inside the rocket. It's bubbling up. It's kind of, the pressure is increasing, and it's got nowhere to go because we have a cork stuck in our bottle. And after a while, this pressure gets too high, and it pushes the cork out of the bottle. And when it pushes the cork out of the bottle, we get this jet of liquid and gas that comes out of the bottle, and that propels our bottle upwards. So that's what we're doing. You know, there's a lot of science that's going into these bottle rockets, because we have to overcome gravity. We have this neutralizing reaction, and then we've got Newton's third law as well, which forces the bottle upwards, because that force can overcome the force of gravity. So we've talked a bit about acids and bases. So how else could you get a neutralizing reaction using other liquids? So here's the pH scale. It's from 0 to 14. And we've got all these different kind of materials here. Looking at this chart, does anybody have any other ideas of how we could get a neutralizing reaction? So we could try lemon and soap. If we mix lemon and soap, we're going to get a neutralizing reaction. If we mix wine and milk and magnesia will get a neutralizing reaction. Basically, if you mix any acid with any base, you will get a neutralizing reaction. That doesn't necessarily mean you'll get pressure buildup, but you will create water because that's how these reactions work. So that kind of covers everything we want to talk about today. That covers everything to do with our, we've talked about gravity, we've talked about the kind of propulsion laws, we've talked about the chemistry of reaction, acids and bases, and we've had a look at that kind of bottle rocket. We've had a look at building that, and hopefully some of you are on your way to getting that launched over the next week. So just to kind of talk a little bit about the challenge we want to run. So over the next week or so, if you guys, so we'll record this, we'll put it up on our website, and you guys will be able to watch this back at any stage that you want. So if you guys want to go and launch those rockets, follow the steps that we've talked through. So take a picture of your rockets as well, because we'd love to see all your designs. We're going to put those up on our website. It's going to look great. And we're going to have prizes going for that as well. So if you take a picture of your rockets, send them in to us anyway. And as well, if you can take a video of you guys trying to launch your rockets, we're going to look through all of those, and we're going to pick out some of the really, really good ones. And we're going to we have some prizes from Blackrock Castle Observatory here in Cork to give out. So we got some t-shirts, we got some hoodies, and we got some like build yourself kits of like solar systems, and we got lots of cool stuff to give out. So make sure you personalize it, make sure you make it look great, make sure make it look cool, put a lot of work into the design. And if you send all that stuff into us, we can put that up on our website, and when we come back for the next session in a few weeks, we'll be able to talk through it as well. So that's kind of everything we have for you guys today on the kind of schedule. But does anybody have any questions on that? Any kind of questions on the lessons, or any questions on the bottle rockets, or just kind of anything in general?
Good, guys.
Everyone good?
Yeah, so
Okay.
we can try the rockets during the week if you want, as Faker said, for the challenge. And then our next lesson, we'll be doing a bit of programming our own game to navigate us through space. So you don't want to miss out on that.
I was just showing Ben here how we have a pH test kit, and we put the vinegar in, and it was like an orange.
Oh, very cool.
Oh.
Yeah.
That looks great. I think the Wi-Fi might have dropped again. Did it there? Is it just me?
Yeah, it's just dropped there a second.
Okay. That
that's
looks
cool.
great though. And yeah, there's lots of different ways you can test for vinegar. You can are you back there? I think your Wi-Fi might have just dropped there for a second.
Yeah, I was just explaining that with Ben. I was just showing him how.
Oh. Gone again.
Technical difficulties, yeah.
That's okay.
Are the rest of you going to try build your rockets? Yeah.
Great stuff. And if you guys have any questions over the week, our email is, it's missiontomars.stemacademy@gmail.com. All your parents will have that anyway. And we've got our website that your parents know about as well. Make sure you can send us an email. You can get in touch on our website. You can ask us any questions that way, and we're going to keep an eye on all that stuff. So if you guys have any questions on the rockets, any questions about the competition, or just any kind of general questions at all, just reach out at any stage. And yeah, look forward to seeing you in 2 weeks' time. In 2 weeks' time, we're going to do a bit of coding. We're going to play a game on Scratch. I don't know if any of you guys have heard about Scratch. But it's like a kind of a coding for beginners website where you can kind of learn about how that works. We're going to play a game about landing our rocket on Mars, and that's great. So make sure you come back for that. And we're going to talk about asteroids. We're going to talk about different kind of asteroids you see in space, and yeah, it's going to be great. So if you guys can make it to that, I'm sure you'll enjoy it. And is that everything? I think that's everything from me anyway, Sarah. Do you guys have anything to add?
No, I just can't wait to see the pictures now of all the rockets.
Yeah, me too. It's going to be great.
Brilliant, guys. Well done today.
Well done.
Thanks, guys.
Thanks, guys. See you next
Bye,
time.
everybody.
Bye. Bye.
Bye.